All right, let's just dive right in. Today, we're going to peek behind the curtain of the internet. We're going to uncover these invisible rules of the road that make everything you do online, I mean everything from sending an email to binge watching a show, actually work.
Really think about it for a second. It's something we do all day, every day. You hit send, and poof, it basically shows up instantly in someone's inbox, maybe halfway across the planet. But what's really going on in that split second? How does the internet know where to send it? And more importantly, what to do with it once it gets there?
Well, the key to understanding all of this is a surprisingly simple idea. Just picture the entire internet as this massive, global highway system. Seriously, just like the roads and freeways we drive on, it's this huge public infrastructure that's just designed to get stuff from point A to point B. If you can grasp that one idea, you're going to get everything else we talk about.
So if we stick with that highway idea, it really breaks down into two main things. On one side, you have the roads themselves, right? The actual pavement, the infrastructure. In the internet world, these are protocols called TCP and UDP. Their only job is to provide the path. Then on the other side, you've got all the vehicles driving on those roads, the cars, the trucks, the vans. These are what we call application protocols. And they're the ones that decide what's being carried and the rules for how to handle it. And this is the really cool part, the core principle of how it all works. The highway itself, it doesn't know or care if a truck is hauling furniture or if a mail van is full of letters. Its only job is to provide a reliable path for that truck to drive on. The internet's transport layer works the exact same way. Without those application protocols giving them meaning, the raw data streams would just be a jumble of meaningless ones and zeros.
Okay, so if the roads are just there to provide the delivery route, let's talk about the vehicles themselves, because this is where the internet really gets all of its special powers. Let's meet some of these digital vehicles. And check this out. The analogy maps out perfectly. When you're browsing a website, you're using HTTP. Think of that as a big old truck delivering a web page right to your browser. Sending an email, that's your digital mail van, SMTP. Need to move a huge file? Well, that's FTP, a dedicated cargo truck for heavy lifting. And DNS, that's kind of like the taxi driver who knows every address in the city and can give you directions to get anywhere you need to go.
So, the analogy is great for getting the concept, right? But let's see how this all clicks together in a real-world situation. Let's actually follow the journey of a single email, right from the moment you click that send button.
So it's really a four-layer process. First, at the top, the application layer. Your mail van, SMTP, gets the email all formatted and sets the rules for the trip. Then, it hands it off to TCP, our highway system, which chops it up into little packets and makes sure it's all going to get there in one piece. Next, the IP protocol acts like a GPS, figuring out the best route for those packets across this huge network of networks. And finally, way down at the bottom layer, things like Ethernet or your Wi-Fi physically turn that data into electrical signals or radio waves and send it on its way. Each layer just does its one job and passes it down to the next. It's beautiful.
So when you really boil it all down, this whole incredibly complex system is running on just two essential complementary rules. It's all about the how and the what.
First up, you've got the transport mechanisms. This is your how. This is the highway system, your TCP and UDP. Their one and only job is to define how the data gets from your machine to its destination. It's the delivery service, pure and simple. But just delivering something isn't enough, is it? You also need the application protocols, the cars, the trucks, the mail vans. They define the what. They give the data its meaning. Is this a web page? Is it an email? Is it a file? These protocols provide the context so the computer on the other end actually knows what to do with the bits it just received. You see where this is going, right? You absolutely cannot have one without the other. A highway with no cars on it? Useless. Cars with no roads to drive on? They aren't going anywhere. As the source material puts it so perfectly, that's why we need both.
And what this creates is just a perfect partnership. The transport layer, TCP and UDP, they just provide the raw, reliable delivery. And the application layer, with things like HTTP and SMTP, they provide the crucial context and the rules. Together, you get a system that is both incredibly strong and unbelievably flexible. So, the next time you send an email, you'll know it's not some kind of magic. It's just a little mail van hopping onto a very, very well-organized digital highway. And that kind of leaves you with a final thought. Now that you know the rules of the road for the internet, what other parts of our digital lives are secretly running on these kinds of simple, clever rules, just waiting for us to understand them?